The screen is visible.
Yes, ma'am.
The number of topics in your syllabus is very less, and anyhow you are going to study only 3 units. So try to understand the logic, then you study. For all the logic like stack, queue, linked list, and the sorting, searching, you need to remember at least the programming logic or the pseudocode. If you know if you are strong in the pseudocode, if you write the pseudocode, most of the concepts, the pseudocode is not more than 5 lines or 10 lines, not more than 5 6 lines. If you write the pseudocode, and from the pseudocode you can write the corresponding C program or C++ or Python program, and based on the pseudocode you can write the algorithmic steps also. So the questions will be like this one: what is exactly stack, and what are all the operations we can perform with the stack? What is the difference between queue data structure definition, uses of queue? So the uses of queue data structure is waiting the list for a single shared resources like a printer, CPU, call center systems, or phone upload, photo uploads. First one to arrive is processed first. The asynchronous data transfer like by pipes, file input, output, and sockets, especially used in Linux and Unix operating system. The buffers in applications such as MP3 players and CD players. So MP3 CD players, they are sequential access. If there is no display, directly it will play one by one. What is the definition of doubly linked list? Give some specific examples. So the music playlist with the next and previous navigation. Next and previous. So we already discussed. So we can do the do and redo, do and undo, and recently visited pages in the web browser, do and undo functions in the browser. So if you are strong in Python, you can write the program. If they're asking you, write the algorithm. If you remember the algorithm, write the algorithm. If you don't know the algorithm, then you write the pseudocode. If you don't know pseudocode also, then you write the program. For all the concepts, you should remember at least any one algorithm, pseudocode or program. If you are strong in any one aspect, from that you can easily convert that into another form. Write a program to perform the bubble sort. So it is almost like a pseudocode bubble sort. So the number of lines will be very less in Python compared to C and C++. What are the benefits of using? What is mechanism behind selection sort? What are all the examples of divide and conquer algorithms where we are using it? So in as per our syllabus, we are using the divide and conquer algorithm in binary search, merge sort, and quick sort. What is the linked list and how to implement the linked list? Okay, any doubts so far?
No, ma'am.
So we already discussed. So if you take the first unit, As we discussed in the previous classes, it's having only 6 topics. We can make the first two important topics: algorithm and data structure. Algorithm introduction, algorithm design, and complexity. So, algorithm design and complexity, they are the two topics very important. Anyhow, they need to ask one question from first half and another question from second half, because totally you have 5 questions for 10 marks in your mid exam. So 10 for 10 marks, they may ask one question with the 10 marks or two 5 mark questions. And they're supposed to ask 2 questions from each unit. So definitely you can expect one question from algorithm design or complexity and asymptotic notations. Complexity and asymptotic notations both are same. Complexity means time and space complexity, and how it is categorized means using the representations, asymptotic representations, big O, big omega, and big theta, and within that, worst case, and average case, space and time complexity. And in algorithm design, we are talking about the steps. What are all the steps we have to follow while designing the algorithm for any given real-time problem? So what are all the steps means? Analyze the problem, identify the problem statement, then state the algorithmic statements, then go for coding and draw some diagrammatic representation, flowchart or a data flow diagram. Then go for the coding and implementation, validate, test, and check the constraints. And if you take the second part, data structures, we have classification of data structure, two major types, primitive, non-primitive. Primitive or basic or fundamental inbuilt data types, integer, character, float, and pointer. And non-primitive means linear and non-linear. Linear is array, stack, and queue. Non-linear is trees and graphs. So those things you need to remember that you might have studied already in the C roots using C++ as well as fundamentals of programming. If you take abstract data type, here we are talking about only data and data structure, user-defined data structure. But in case of abstract data type, we are talking about the data structure along with the functions. So data structure plus function is called abstract data type. Like stack, queue, linked list, each one is associated with the variables along with its operations. So we saw what is the definition of algorithm. Every algorithm should be designed in such a way that accepts some input, does some process and produces the expected outcome. And say for example, if you are designing an algorithm for finding the sequence of n numbers, sorting, you are giving an unsorted list of n numbers. The algorithm should produce the output in a sorted form of n numbers. Then we discussed in what is the relationship between data structure and algorithm means. So our subject is all about data structures and algorithm. It talks about data structure as well as algorithm. So data structure talks about the various user-defined data types are built in by created by the end user-defined data types by making use of the built-in or primitive data types. The linked list, matrix, queue, stack, array, graph, tree, string, all those things are user-defined data types, and it's having its own variables along with the functionalities. And those data types can be applied with the various types of algorithmic methods. Different types of algorithmic methods like pattern searching algorithms, divide and control algorithms, searching algorithms, sorting algorithm, greedy algorithms, recursive algorithms, backtracking and mathematical algorithms, dynamic programming algorithms. Like that, we have a number of algorithmic types, out of which we are in your syllabus. We're going to study. You studied first and second unit, third unit, divide and conquer algorithm, sorting algorithm, and searching algorithm. Second unit we discussed about sorting and searching algorithm. Third unit we are using brute force approach algorithm and divide and conquer algorithm. In fourth and fifth unit we may be using greedy algorithm along with the graph, and recursive algorithm also be used. So any problem we can solve it using mathematical formulas, direct mathematical formulas, or by using iterative methods, or by using recursive methods, or by using divide and conquer approach. If you are going to perform sorting and searching, you can make use of the sorting methods like quick sort, cell sort, merge sort, insertion sort, selection sort. Searching methods like binary search, sequential search. Then we discussed what is algorithm design, what are all the steps we need to follow in algorithm design, define the problem, specify the algorithm, analyze the algorithm, and implement the algorithm. Implementation means based on the algorithmic steps and based on the diagram, you have to write the corresponding code. After compiling and executing the program, check for errors, check for the efficiency, then accordingly you debug and eliminate the errors. Then try to optimize by changing the steps or by changing the logic or using an effective algorithm. So these are the steps we need to follow in algorithm design. So the algorithm design is somewhat important topic. We taken an example. So we discussed along with bubble sort. Bubble sort is also one of the topic in your syllabus. The pseudo code for bubble sort, and we taken some 5 numbers. Based on the numbers, we performed the iterations. First iteration, second iteration. Here we are using for loop I equal to 0 to n minus 1, for loop j equal to 0 to n minus I minus 2. So when I is 0, j is 0, how the process is done. When I becomes 1, j becomes 1, 2, how the nested for loops are performing. So that we need to discuss. Then corresponding program. So what is the algorithm design, then sample as bubble sort, and what are all the steps we are following in bubble sort, algorithmic steps, pseudo code for bubble sort, example and explanation with the sample input output, and the program implementation of bubble sort using C++ program, main program and sorting bubble sort procedure. Then we discussed about complexity, time and space complexity, and how it is represented using a graphical notation. The time complexity represented in T of n form, S of n form. They may ask you how the quick sort you are getting the time, but so and so time complexity, because the quick sort is the more efficient sorting method. In best case, it is order of n log n. How you are getting? In worst case, we are getting order of n square. How you are getting that particular n log n and order of n square compared to other merge sort and bubble sort. And the time complexity can be categorized as constant or linearly increasing and quadratically increasing and exponentially increasing. Say from this diagram, it is constant or always order of 1 with respect to number of inputs and time, CPU time. This is exponential order of x square, and the linear is order of n log n, and quadratic is order of x cube, and exponential is order of n factorial as well as order of 2 to the power of x. So based on the algorithm with respect to time and the number of inputs, the algorithm may produce the complexity in constant form or a linear form or exponential form, quadratic relationship, or it may be exponential. Then this particular table gives you the complete idea about the various sorting and searching methods what we had in our syllabus: quick sort, merge sort, the three brute force approaches, selection sort, bubble sort, and insertion sort. What is the best case, average case, and worst case, and what is the space complexity? How we are classifying the complexity means time and space complexity. And the asymptotic notations are big O notation. It is upper bound and worst case scenario. Big omega notation, lower bound and best case scenario. Theta notation, exact bound by calculating the lower bound and upper bound and taking the average. And here we taken the insertion sort, how we are calculating, getting the time complexity in best case, average case, and worst case, and the corresponding graphical representation: constant, linear, exponential, and quadratic and exponential. Big O notation and big omega, big theta notations. Say here they given a function f of n, and how we are getting the time complexity and space complexity with respect to big O, big omega, and big theta. So we are using a master theorem for the divide and conquer recurrences in the form. Say for example, if we are given an expression to solve the given recurrence notation and provide the theta, that is average case, exact bound, we can use the master theorem for the divide and conquer recurrence relation. So the master theorem provides three cases: best case, worst case, and based on the asymptotic notations: best case, worst case, and big O, big omega, and big theta. Given any representation, say here they given a 80 n by 2. So if you take the value, some value a as 8, where 8 is the constant error factor. Now you compare these expressions based on with respect to the master theorem. We are deriving the best case, worst case, and average case. Then introduction data structure, we have classification and abstract data types. We know very well data structures. We are having basic, primitive, and non-primitive, and we have user-defined data structures and various algorithmic steps. Data structure is specific formats for organizing the data and storing it in the computer and applying the algorithms. And what is the data structure and how the algorithms are using the data structures. If you take the classification, we have built-in data types and user-defined data types. Built-in, or they are part of the compiler or programming. They are the programming constructs. By using the basic or built-in data types, we are creating integer array, integer files, or linear array, linear and non-linear. In list, under list, we are getting linear list and non-linear. Linear means the stack and queue, where continuous memory is allotted. Non-linear means the memory will be allotted in different memory locations. We are accessing all those elements are connected with each other through the address. If you take primitive and non-primitive, primitive built-in, non-primitive, arrays, single dimensional, two dimensional, multi-dimensional, list, linear, non-linear, stack, queue, and linked list, non-linear, trees and graphs. The major difference between linear and non-linear data structures is given. From the diagram itself, you can easily understand. Linear means continuous memory location along with the index. Say if you say an array of 5, continuous memory location, because if the array is of integer type, 2 bytes for all 5 elements will be assigned. Memory will be allotted. So 2 into 5, 10 memory locations, continuous memory location will be assigned for the particular array. Each value you can access through the index, A of 0, A of 1. In the same way, stack also continuous memory location. Queue also continuous memory location. Here there is no insertion and deletion point. Here we have insertion and deletion point through the top pointer. Here we have two ways, one way to add, one way to delete. In linked list, we are maintaining the data as well as the address. To take graph and tree, we are using graphs, colored graphs, directed graphs, undirected graphs, weighted graphs. Trees, we are maintaining the family structure, hierarchical relationship, parent, child, grandchild. And then we discussed how the searching is performed using linear search. With what is linear search? Example, and the corresponding linear search is pseudo code, corresponding program. The linear search non-recursive program, linear search using recursive function, Here we are using the recursive linear search. This function is called within the same function. So it is the function calls itself is called a linear recursive function. Then we discussed about abstract data type. The definition for abstract data type is collection of data along with the set of operations that can perform on the data. So if you have data and operations together as a single entity, like classes, we will call it as abstract data type. And the various abstract data types, they, what we are using in the programs are and a data declaration package together with the operations. So data along with the operations that are meaningful for the data type, declaration of the data, declaration of operations, encapsulation of data and operation. So if you put data and operation together as a single entity, we are getting data encapsulation, we are getting data hiding, and data hiding, data encapsulation, and abstraction. All three concepts are applied while creating the ADT. Data encapsulation, data hiding, and abstraction. With we have a number of abstract data types. Say if you take integer, what are all the operations we can perform with the integer means we are declaring the properties of the integer, the number type, positive or negative number, and the operations we can apply on the particular integer variable. Maybe we can add two integers, subtract, multiply, and divide. The examples for abstract data types are stacks, queues, trees, graphs, and tables. Each and every ADT is having its own attributes and the functions. Push, pop, peak, and is empty. They are all functions that can be applied on the stack by using the stack pointer and the size of the stack. The same way queue, we can perform the operations like NQ, DQ, from accessing the front, rear, and the empty using the queue declaration with the front and rear and size of the queue. And the abstract data types can be created using array or using linked list. Then we discussed what is binary search, what is the difference between linear search and binary search, how the logic differs, the performance or computational efficiency of binary search is it is almost constant, but linear search is it is we can say it is in the exponential form. Even if you give 10 inputs or 5 inputs, it's taking the constant time. But if you take linear search with respect to the number of inputs, the computation time increases exponentially. Then we do compared the various linear and binary searching techniques, how the with respect to the number of inputs and the computation time, how it is different. Then we discussed what is binary search, what is the definition, time and space complexity, algorithmic steps, and pseudocode. The major difference between linear and binary search and binary search definition, time and space complexity, then the algorithmic steps, pseudocode, and the program. And example, by taking some sample input output, how the steps are performed. The difference between linear and binary is compared. So the number of topics in unit 1 is very less. If you just go through the topics, you can easily understand. Any doubts so far with respect to unit 1 topics? So are you listening or
No, ma'am.
the screen is visible?
Yes, ma'am.
So if you take unit 2, here also it's very simple, very basic concepts. Sorting and searching techniques using two different algorithmic methods. One is using brute force approach, another one is using divide and conquer technique. But if you take the example for a brute force approach is linear search. You know what is linear search and what is the logic behind linear search, the common man's logic. So based on the linear search logic, you can easily explain what will be the logic behind, because using this logic only the searching is performed. So you know very well how the linear is performed. We will just compare the one element with all other elements, then we will identify whether it is less than or greater than other elements. If it is less, then we will keep it in the first position, and if the first that particular comparing first number is greater than any other, if any other small number is there, that will be swapped with the searching element. So using this brute force approach, we can sort. We are performing bubble sort, selection sort, and insertion sort. These sorting methods also all following the brute force approach. And the divide and conquer, you know, dividing and getting the solution. The binary search, merge sort, and quick sort is following divide and conquer. The topics are only three topics. And the first topic is only general method in both the brute force approach as well as in the divide and conquer approach. We are using this approach, three sorting methods, one searching method. Using this divide and conquer approach, two sorting methods and one searching method. We discussed what is the approach and what is the logic behind that. Most general searching algorithm are called brute force that do not use any domain specific knowledge, and especially the selection sort, sequential sort are using the brute force. What is the technique? What is the working principle? Then what is the divide and conquer approach? In divide and conquer approach, we are following three major steps: divide, conquer, and get the result combined. It's like if all the problems are united, the problem may look very big. But if you the same problem statement, if you divide into small sub problems, and if you get the solution for all the sub problems, and if you merge, then you will get the solution for the whole problem. So we are following three steps: problem, sub problem, to get the solution for sub problem, then merge and get the solution for complete problem. So in divide and conquer, we are using the merge sort is performed using divide and conquer approach. Here we are following the steps: divide, conquer, and combine. It's having its own advantage and a disadvantage. And how the merge sort is performed, what are all the steps, what is the logic, and what is the computational time, and how we are getting the calculating the computation time. All the assignment process, divide process needs order of one, conquer process needs order of one, conquering of two sub problems, 2 into n by 2 n by 2, and combine process also again needs order of n. So the computation time is with respect to number of inputs, and how we are designing, what are the steps we are following, and how it is performed. The big problem n, and divide n by 2 n by 2, unsorted, and merge and sort, and we are getting the solution for n by 2 sorted, n by 2 sorted, merge and get the solution. An example: merge and sort, merge and sort, and merge and sort. So this is the pseudo code for merge sort. It is a recursive procedure. Within the merge sort, we are calling two times, so recursively merge sort and merge. The logic behind merge sort. Then quick sort. What is the definition? What are all the steps followed? In quick sort, it is also recursive procedure. Within quick sort, we are calling the quick sort for n by 2, n by 2, and partition. The partition is performed with respect to the pivot element. The elements which are less than pivot and greater than pivot. In that way, we are sorting. So this example gives you how we are performing the input. We are taking the first number as pivot. So we will need to compare this with all other numbers. and the elements which are less than the pivot will come left hand side. The elements which are greater than pivot will go in the right hand side. So 14 is your pivot. The numbers 12, 13 and 11 are less than pivot. So 12, 13, 11 is coming this side. The elements 16 and 15 is greater than 14. It is coming this side. Again in the sub problem, pivot less than 12, 11, greater than 12, 13. Now it is in sorted. Again here less than 16 is 15. So 15 and 16 it's sorted. It's having its own advantage and disadvantage, and we need to remember the computational time in the worst case and the average case. In the worst case, it is order of n square. In the best case, it is order of n log n. Algorithmic steps. An example. So in the quick sort, we are having following only 3 steps. Take the pivot, partition with respect to the pivot, and perform the sorting recursively with respect to the pivot. The corresponding quick sort program. So main program, within the main program, we are calling quick sort. In main program, we are calling the quick sort once. Within the quick sort, we are calling the quick sort twice. So the quick sort function itself, recursive function. Then we discussed with using rigorous divide and conquer approach, quick sort and merge sort, and binary search. How we are performing binary search means, so make it as find out the midpoint with respect to the midpoint, divide into 2 of and perform the search. So already we discussed with respect to the unit 1 itself, we got the result. So here also the topics are very less. Each and every topic is clearly stated in the PPT. Go through the PPT. And for this, I have given one more PDF file also. For unit 3, already I have given. The screen is visible. Unit 3, yesterday itself we revised. So it talks about stack and queue. And it's also having part A, part B. Part A talks about linked list. Within linked list, singly linked list and doubly linked list, plurally linked list, implementation and application. And part 2, unit 3, part 2, stack and queue, implementation and application, and circular queue application. So what is the linked list? Singly linked list, doubly linked list, circularly linked list, how it is represented, what is the how we are creating the node, how we are initializing the node, what is the doubly linked list, data, previous address, next address, 2 special nodes, head node and tail node, how the node is created with the data field and next field and previous field, how we are initializing the nodes, how we are allocating the memory, what is circularly linked list, the last node points the first node, and in doubly linked list, the doubly linked list node is represented with the data field and previous address and next address. 2 pointer variables we are using. The representation is we are using 2 special nodes, head node and tail node. With the head node and tail node will not carry any data. Only the first node, second node, third node. Other nodes will carry the data as well as address. How it is represented, how the insertion process, adding of elements in doubly linked list is performed. The addition and deletion can be performed in the beginning or in between. In beginning means after the head. In between means any particular position, position 1, 2, 3. At the end means before the tail node. How adding in the beginning means we'll create a new node. The new node is marked as it will point, the previous pointer will take the null value and the next pointer will point the first node. The same way, and we are making this a head node. In between means, in between we will put it and the address reference is changed. At the end means it is we are making the new node as the last node. We are putting next address as null. So the deletion is performed in the beginning, end, and the last. Deleting the first node. So if you remove this connection is removed, and this head node directly points the second node. Then this connection is removed. Head is directly pointing the second node. So the second node becomes first node. The first node is eliminated. Deleting in between. So if you want to delete it two, this connection is removed. This connection is removed. The next points directly to the third node, and the third node's previous points to the first node. So both the connections are removed. So this becomes isolated. Deleting the last node. If you put the previous node as null, then the connection between the previous node and the last node is eliminated. Then this becomes the last node. Okay, any doubt so far? And doubly linked list, what is the complexity? Addition, deletion, and
No, ma'am.
everything order of one. Time and space complexity, everything is order of one. Depending upon on the number of inputs, it may be order of n. And the complexity is time and space complexity is order of one only for addition as well as deletion. And the doubly linked list, where it is applied means redo and undo operations, forward and reverse navigation, and in the navigation systems, GIS, GPS trackers. The difference between single linked list, doubly linked list, here only one address, here we are using two address, two pointers. The traversal, one-way traversal is possible. Here, two-way traversal, forward and reverse traversal is possible because it's having both addresses. It's maintained only forward address, so one-way forward traversal is possible. Because single linked list is maintaining only one address, so less memory space. We are maintaining two addresses, forward as well as reverse address, so we need extra memory space. This can be represented using stack structure. It can be doubly linked list. We can represent using stack as well as heap and binary. So go through the topics. If you have any doubt, ask me in the next class. So the topics are easy. The thing is, you need to study, remember, and understand. We're not expecting you to write the same mugged up definitions. You can use your own definitions, but the logic keyword should be there because of the stack queue linked list. We are using specialized keywords. Those keywords should be used. What is the condition for is empty, is full, that you should remember. The logic behind divide and conquer, quick sort, that you need to remember. So the screen is visible. The meeting will end in another 1 minute. I will take the attendance from the Zoom recordings. So I have uploaded all the materials. You go through it. If you have any doubt, ask me in the next class. And answer all the questions. Divide the time for all the because 90 minutes will be given. You need to write 55 questions. You need to give 15 minutes time for each and every question, and 16 pages are given in the answer booklet. You're supposed to write minimum 3 pages. Within the 3 pages, you have to mention, you have to write the answer according to the question. They're asking you to explain. If they're asking you to define. If they're asking asymptotic notation, use the notation and mention the complexity. If they're asking you to draw the flow chart, write the algorithm, explain the pseudo code, explain with